Hi, welcome back. In this video, we are going to be talking about graphing square root inequalities in two variables. The process is very similar to the process we've used before for graphing inequalities in two variables like linear and quadratic inequalities. There's just one additional step that needs to happen regarding the restricted domain of the square root function. So our first step is that we're going to find the domain of the related equation. So we're going to start by looking at our original equation and deciding what the domain is of that. Then we are going to graph the boundary with the appropriate line type. A dashed line with an open circle if we have a less than or a greater than, a solid line with a closed circle if we have a less than or equal to or a greater than or equal to. Then we're going to draw a vertical dashed line at the boundary of the domain. Then we're going to check a point in the domain of the inequality. So we're going to decide which side of the graph will get shaded. Then we're going to shade as appropriate. And as a last step, if the inequality is less than or equal to or greater than or equal to, we need to change the dashed line from our boundary to a solid line only for the portion of the graph that is shaded. If we have a less than or a greater than, this isn't going to be an issue. So let's take a look at a couple examples. So our first example is y is less than x minus 4 minus 6. So our first thing is find the domain of the related equation, and the second one is graph the boundary. So what I'm going to start by doing is finding the related equation. So this is the square root of x minus 4 minus 6. So the domain of this function here, the domain comes from the fact that we can't put a negative number under the square root. So this is x minus 4 needs to be greater than or equal to 0. So x needs to be greater than or equal to 4. So I'm going to come over here and I am going to graph a dashed line at x is equal to 4. So 1, 2, 3, 4. So now I will graph this. So now I have the dashed line, x is equal to 4. So now that I have that, I am going to graph the boundary with an appropriate line type. So now I am going to use the process from our last set of videos on graphing square root functions, and I am going to start by finding the vertex. So the vertex is the point that is on this domain restriction. So I'm going to find the y value that relates to that. And that is going to be at the point 4, negative 6. This is my vertex. So at 4, negative 6, I am going to put an open circle. And I know it's an open circle because this is a less than. So that means I will have an open circle and a dashed line. So at 4, negative 6, 1, 2, 3, 4, 5, 6, I will have an open circle. And I'm going to mark this as 4, negative 6. I can tell this graph is going to open up, but I want to know a couple other points on this graph. So I have 4. If I plug in, so I have 4, negative 6. I know if I plug in 5, I should get the square root of 1 minus 6, which will give me negative 5. If I plug in 8, I should get the square root of 4 minus 6. This will be 2 minus 6, which is negative 4. So I have 5, negative 5, 6, 7, 8, negative 4. And I'm going to graph this with a dashed line like that. So this is a dashed line. It starts at the point 4, negative 6, and now I need to check a point. So the point I'm going to check, I am going to go ahead and I am going to test this point here. I'm going to check the point 5, 0. So I will be checking the point 5, 0. And I'm checking this point in the original inequality. So this is 0 is less than the square root of 5 minus 4 minus 6. 0 is less than 1 minus 6. 0 is less than negative 5. This is not true, so I am going to shade this portion. Because the inequality is less than, not less than or equal to, we're not going to worry about this part. All right, moving on to this next question. We have y is greater than or equal to 4 times the square root of x minus 2 minus 12. So I need to find the domain of this. I'm going to start by just finding what this inequality, what the related equation is, and that is y is equal to 4 times the square root of x minus 2 minus 12. So the domain of this is that x minus 2 needs to be greater than or equal to 0. So that is x is greater than or equal to 2. So I'm going to go ahead and graph that x is equal to 2. And I'm going to label that so that we can see what that is. So that relates to my vertex. This value of 2 relates to my vertex. My vertex will be on this line. So y is equal to 4 times the square root of 2 minus 2 minus 12. This ends up being 0 minus 12, or y is equal to negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that point down there, because of this, it will get graphed as a shaded circle and a solid line. So this is the point to negative 12. All right, so now I need to find a few more points on my graph. So I had the point to negative 12, and now I need a couple more. So if I plug in 3, I should get the square root of 1. So that would be 4 times the square root of 1 minus 12. That's 4 minus 12, or negative 8. If I plug in 6, I should get 4 times the square root of 4 minus 12, which is 8 minus 12, or negative 4. So I have the point 3, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. And then I have the point 6, negative 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And this will get graphed with a solid line that looks like that. So now I'm going to pick a point to test. I'm going to test this point. I'm going to test the point 3, 0. So I'm checking the point 3, 0 in my original inequality. So 0 is greater than or equal to 4 times the square root of 1 minus 12. That is 0 is greater than or equal to 4 minus 12. 0 is greater than or equal to negative 8. That is a true statement. So I shade this portion. Because this is a greater than or equal to, this boundary will be graphed with a solid line, only up until this point. And that's how you graph quadratic inequalities. Every point in the shaded region represents an ordered pair solution to the original inequality that will make a true statement.